Hi, this is Ramachandran from onlinemathforall.com. In this video, we are going to see proving trigonometric equations using identities. To learn how to prove trigonometric equation using identities, we can consider an example, that is sine to the power 4 theta positive cos to the power 4 theta is equal to 1 negative 2 times sine square theta times cos square theta. Okay, in this example of trigonometric equation, we have two parts. One is on the left hand side and other one is on the right hand side. So okay, we can consider the left hand side of this equation as LHS, that is left hand side, and we can consider the right hand side of the equation as RHS, that stands for right hand side. Now to prove this trigonometric equation, I am going to take the left hand side and show it as right hand side. Okay, now we can take the left hand side of the equation, that is sine to the power 4 theta positive cos to the power 4 theta. Okay, in our next step, what I'm going to do is I'm just going to write sine power 4 theta as sine square theta whole square positive cos square theta whole square. Okay, to understand the second step of our problem, let us consider the term x to the power 4. So in our term x to the power 4, we have 4 at the exponent. Now I'm going to write the 4 as 2 times 2, because the multiplication of two numbers 2 and 2 will be equal to 4. So now here we have two numbers multiplied at the exponent. Whenever two numbers are multiplied at the exponent, it can be written as power again to the power. So power to the power. So x power 4 can be written as x to the power 2 again to the power 2. So in this way we can write sine power 4 theta can be written as sine square theta whole square. In the same way, cos power 4 theta can be written as cos square theta whole square. I hope now the students will be able to understand the second step, that is sine square theta whole square positive cos square theta whole square. Okay, now I am going to consider another algebraic identity, that is a square positive b square positive 2ab is equal to a positive b the whole square. Okay, already we are much familiar with this particular identity, that is a plus b whole square is equal to a square positive b square positive 2ab. In this identity, I am going to make a little change, that is I am going to take negative 2ab on both sides. So when I take negative 2ab on both sides, I'll be getting a square positive b square is equal to a positive b the whole square negative 2ab. Here positive 2ab and negative 2ab will get cancelled. So from the identity a square positive b square positive 2ab is equal to a positive b whole square, if we make little change, we get a new identity for a square positive b square, that is equal to a positive b the whole square negative 2ab. Now we can come to our original problem. So now we are in the step of sine square theta whole square positive cos square theta whole square. Now it's in the form of a square positive b square. So if you compare this one and this one, that is sine square theta whole square positive cos square theta whole square and a square positive b square, we have sine square theta instead of a, we have cos square theta instead of b. Now I am going to apply the identity here, that is a positive b the whole square negative 2ab. So because that is the identity we got for a square positive b square, in the same way I am going to write my problem, that is sine square theta whole square positive cos square theta whole square. Here instead of a we have sine square theta, instead of b we have cos square theta. So in this identity, instead of a I am going to apply cos sine square theta, instead of b I am going to apply cos square theta. So when I apply, so I'll be getting sine square theta positive cos square theta negative 2 times sine square theta times cos square theta. So this is what we are getting for the identity a positive b the whole square negative 2ab, in which instead of a I have applied sine square theta, instead of b I have applied cos square theta. Okay, we can proceed the next step on our next page. Okay, the last step in our previous page is sine square theta positive cos square theta whole square. I'm sorry, I missed the square part here. So whole square negative 2 times sine square theta times cos square theta. So already we know that the value of sine square theta positive cos square theta is 1. So that is also an identity in trigonometry. So we can replace the part sine square theta positive cos square theta by 1. So it will be 1. So we have square for this part. So we take square for 1. Negative 2 times sine square theta times cos square theta. So 1 negative 2 sine square theta cos square theta. So this is exactly RHS. So now we get the proof LHS is equal to RHS. So I hope the students will be able to understand how to prove trigonometric equations using both algebraic and trigonometric identities. For more videos like this, please visit onlinemathforum.com. Thank you.